we're going to look at the solution to this. The reason why I've chosen this one is it has one particular thing in it that could be in the actual assessment, all right? So it's a technique that is used to find a general solution, okay? So if we read it, it says, Felix works alone in his furniture factory. He makes bookshelves, chairs, tables from pine timber. Each month, Felix has a supply of 1,750 metres to use and works 160 hours each month. How much timber he uses and how long it takes for each item is outlined below. Task 1. Felix decides to make 4 times as many chairs as he makes tables. Explain to Felix how many of each item he should make in a month. All right, so we start off with looking for the variables. They've told us the variables are bookshelves, chairs, and tables, which quite nicely, and usually this happens, they have different letters that start each word. So we stick to those letters rather than X, Y, and Z, which mean nothing. So the first thing we always do is define the variables. So we're going to write B equals bookshelf, C equals chairs, T equals tables. We could now form a table to find our equations. So in case you want to, but some of you would be able to go straight from here to equations. So what have we got? We have got 50, I put here B, C, T, and timber. We've got 50, 25, and 120, and we've got at maximum 1750 metres. For hours, we've got 5, 4, and 3 with a total of 160 per month. All right, so we've got these two. The problem is we haven't got another one. We have got a hint at another one in the task. Felix decides to make 4 times as many chairs as he makes tables. Now, this is that equation that I was talking about the other day that can go right or wrong. All right, so we have got 4 times as many chairs as tables. Anybody want to suggest which way around it goes? C equals 4T is correct. So if we are making the C's and T's on the same side, we get C minus 4T equals 0. So filling in our table, we would have nothing here, no bookshelves, 1 C, 1 chair, negative 4 tables, and 0 here. That now gives us our 3 equations, which of course to pass the standard, we have to write as equations. So we're going to write them as 50B plus 25C plus 120T equals 1750. 5B plus 4C plus 3T equals 160. And I'm going to put no B's just so that I remember to put it in my calculator correctly. And minus 4T equals 0. All right? So to pass the standard, defining the variables, writing the equations from graphics calculator, we're going to put it in our graphics calculator. So we are putting it in equations, menu equations, under simultaneous equations, which is F1, under 3 variables, we get the nice matrix, we fill it in from here. So 50, 25, 120, 1750, 5, 4, 3, 2, 1, 0, no, 160, 0, 1, negative 4, 0. Solve it. We get a nice whole number answer, so we hope that therefore we have put it in correctly. If you did happen to have put this around the wrong way, which I did when I was practicing, I put T and 4C. I got half answers. So I kind of knew I was wrong because they're always going to give you something that's nice for the achieved one. So I went back and asked myself the question, chairs for, right, it needs to be C equals 4T. Okay, so if you don't get something you expect here, go back and look at your equations or look at the fact that you might not have entered it properly. You saw a 5 here and you read it as a 6 or whatever. Okay, so we get 13 for B, 20 for C, and 5 for T, which tells me not very much because I don't understand it. So I need to write it out as an answer. Felix needs to make 13 bookshelves, 20 chairs, and 5 tables. Right, we most definitely have it covered, our achieved now. No problems there, 3 credits coming our way. For task 2, it says, Felix finds his business is growing. He decides to make 6 times as many chairs as tables, keeping his other requirements the same. Explain to Felix why this is not possible. So we're going to change this equation here. So equation 3 to 0 bookshelves, 1 chair, 6 tables equals 0. That isn't 6 tables, remember. The T is the tables. The C is the chairs. It doesn't say 1 chair and 6 tables up there like I just said. Okay, it's just part of our working out. All right, so when we put this in our calculator, so if we just quickly go back and change that -4 to -6, yes, you should do this, even though you know it's probably not going to work, just in case it does and you waste all your time. There's my error. I know now that it doesn't work, but I have to explain to Felix why it doesn't work. That's part of it. So in explaining to Felix, I need to say what system of equations we've actually got. So I'm going to have to solve this by hand. So to solve this by hand, I am going to take 1 minus 10 times 2, which is 0b. 1 minus 10 times 2 is a negative 15c. 1 minus 10 times 2 is positive 90t. 1 times 10 times 2, 10 times 2 is 150. All right, so 1 minus 1600. All right, so once I've got to there, I've now got 2 equations, calling this one now 4 because I've changed 3. Got these 2 equations, so I want to do 15 times 4 plus 5. So the 0b's don't need anything, we're not even going to write it down. 15c plus minus 15c gives me no c's. 15 times 6 is negative 90, plus 90 gives me no t's. 15 times 0 plus this gives me 150. So I'm at 0 equals k. Now we've talked about the fact that 0 equals k indicates to us that
no real solution.
No real solutions. All right. What else are the other words we use? Inconsistent. All right. So it's inconsistent system. We need to use all the words. And now, which situation do we have? So we look at our equations and we say, we don't have any parallel planes. Therefore, the only situation we can have for this is a triangular prism, right? So that to have an inconsistent system, we've got to either have parallel planes, in other words, they don't meet, or we've got those three meeting at lines. So we've got this situation, right, with this triangle. So that's our explanation. So if this was the whole assessment, we would now have got excellence. All right, but it isn't the whole assessment. There's another part to it. So the last task says Felix wants to use the ration of 6 chairs to every table and still wants to use the 1,750 metres timber each month. Explain how Felix can change the number of hours he works each month to find a suitable production plan. Right, so that's all way out there. So we need to bring it back to maths and say, okay, let's say his working hours are H. What does that do for us? It means that if everything else is the same, we can change the equation that is about hours to 5b plus 4c plus 3t equals H. How many hours do we need for him to make this work? We're going to find that H. And how are we going to do that? In the same way that we have done everything else. So we've got our equations, this one, which was 2, this one, which wanted to stay the same, and this one, which is the ration of chairs to tables. So those are our 3 equations we're working with. If we start to solve this, we know that this part of it drives us to a 0 situation. We want to solve what happens on this side of it, which is where H is hanging out. So if we do the same thing we did here, we will end up with, so 1 minus 10 times 2 is no B's, minus 15 C's, plus 90 T's, and now we've got this minus 10H. All right, so we've got an H involved in it now. So if we now use the no B's and this one here, so if we multiply this equation, so our new equation 3, by 15, we get 15C, negative 90T, and 0. When we subtract these two, calling them 4 and 5, because we like numbers in order, 4 minus 5, so negative 15 minus, adding them, negative 15 plus it gives no C's, 90 minus it gives no T's, this one plus this one gives us this. Now, we don't want that to be a number, we want that to be 0, right? Because 0 gives us solutions. Lots of them, dependent solutions, but gives us solutions. So if we solve 1750 minus 10H equal to 0, we will get 175. So 175 hours is the ideal. But that now gives us our 0 equals 0 situation. So we've got a dependent system, which means we've got multiple solutions. Here's where the excellence comes. We don't want to just say that. We want to find solutions. And what we need to do is take it back to the actual situation. All right? Back here, we can't have negative bookshelves, chairs, or tables. We can't make negative bookshelves, chairs, or tables. So therefore, we actually have the three planes, because it's a 0 equals 0, no parallel planes. We have that book situation, all right? So three planes meeting on a line. So we would have that situation of a book looking there. But not all of these are answers. Some of these will take us into the negatives for our bookshelves or our chairs or our tables. So we need to find out where that actually doesn't happen. So what we're going to say is that T equals K. We're going to say the number of tables we got is K. We would now like to relate everything else to that K. So in our equation here, we've got 1 chair minus 6t equals 0. That means that we have got 1c minus 6. We've got c minus 6k equals 0. So c equals 6k. All right? That's all good. They're positive numbers. We're fine. But in our last one, which we're going to go back to this one because it looks nicest, so in 2, we've got 5b plus 4 times 6k, because that's what c is equal to, and 3 times k, because that's what t is equal to, equals 175. All right? So we've got 5b plus 24k plus 3k equals 175. So we've got 5b equals 175 minus 27k, or b equals 35, 27, 5.4k. Right, so we've got b equals 35. So, just erase this bit over here. What does that tell us? It tells us our general solution in terms of B, C, T is 35 minus 5.4 T, no K, 6K, and K. So all of our solutions are now related to K. This K is what we're trying to find. So that first one tells us the bit we need to know. Okay, we know that K can't be less than 0. All right? Because if it, can't be less, can't be less than 0. Can be equal to 0, can't be less than 0. Because if it's less than 0, we've got negative somethings. In this case, we've got negative tables. Okay? Not true in our situation. If it was completely algebraic, yes, it would be true. But we're dealing with furniture, can't have negative tables. All right? So what else is true? This one here, also can't be less than 0, because that would mean that that is negative bookshelves. So if we solve this one, so 35 has to be greater than 5.4k. So k has to be less than 35 divided by 5.4. which is 6 point something. Any hints?
6.48.
Okay. We don't actually care about the 4.8 because we don't have 4.8.48s of tables and things either. So what we're saying here is that K can't be less than 6. Or has to be, sorry, less than 6 to work. So now we've got between 0 and 6 as our K. Now, taking it back again to the fact that we have to have whole things, we try out K equals 0. If we have K equals 0, that means tables equals 0, right? Chairs will equal 0. And bookcases will equal 35 minus 5.4 zeros, so 35. So there's a solution that will work for his 175. He can make just 35 bookcases. If we try 1, we get T equals 1, C equals 6, and B equals 35 minus 5.4. We're into our half bookcases again. So B is not a good number. So actually we don't care about 1. So we try 2, doesn't work either. We try 3, doesn't work either. We try 4, still not working. And we get to 5, which of course 5 times that 0.4 is going to give us a whole number. So 5 is going to work. So our next solution is at 5, which means we've got 5 tables, we've got 30 chairs, and we've got 35 minus 5.4 times 5, which is 27, so 35 minus 27, which is 8 bookcases. We go to 6, we're back to that situation of that part, so there are our 2 answers. One is make this, one is make this. That's all the answers that work for the situation we've been given. And that is now a beautiful excellence.